Hi everyone. Today we are going to discussing about the plate tectonism and its processes. So the plate tectonism is the process of movement of tectonic plates. So what is this tectonic plates? So the tectonic plates are the parts of the earth crust. So the earth crust is divided into number of lithospheric plate, so including oceanic lithospheric plates and continental lithospheric plates. So this crust is just above the astrosphere. So the Earth is physically it is divided into three. That is, the inner part of the Earth is called core, and middle part of the Earth is called mantle, and outermost part of rocky layer of the Earth is called crust. So this crust is again divided into continental crust and oceanic crust. Especially this denoted as the oceanic plate and continental plates. So this is made up of rocks. So there are different kind of plates are above the Earth's surface. About 21 plates are there in the Earth's surface. So among these plates, the oceanic plate, that what do you call that plate is called Pacific plate. So this is very largest plate on the Earth's surface. So there are continental plates are there. So this African plate, Australian plate, American plate. So there are European plates. There are different kind of plates out there. Indian plate is another one plate, including these plates, continental plates. And oceanic plates are Pacific plate, Atlantic plate, Nazca plates, Cocos plate, Mediterranean plates. So there are different kind of marine plates or oceanic plates are there. So this oceanic and continental plates are continuously moving in a specific velocity above the astrosphere. So this astrosphere is the just below the lithosphere or these plates. The astrosphere is just below the lithospheric plates. So that is the upper part of the mantle. So this astrosphere has a plastic nature because of the heat. Okay. So these plates are floating along the astrosphere. So this kind of movement of plate is called plate tectonism. So there are different kind of causes for this plate tectonism. So this is the distribution of the plates along the Earth's surface. So this is a different kind of plates, African and American plates. This is the most largest plates on the planet, that is Pacific plate. So here you can see different kind of colors. So these colors are indicating the mountain ranges. It's very mountain ranges of the continental part that is associated with the plate interaction. So we will discuss it another slides. So the causes of the plate tectonism. So that is a mechanism of the plate tectonism that is including the convection current in the mantle. So the mantle is also, we are already discussed about the mantle, that is what you call the melt or the semi-liquid state of mantle is the cause of convection currents. So this convection cell or the convection currents is formed by the heat transfer within the mantle. So the convection is the process that is a heat transfer through the liquid. So liquid means this is a semi-liquid or semi-solid condition in the mantle because of the heat. So all the rocks are in the semi-liquid or semi-solid condition in the mantle because of the heat. So this plastic material in the mantle or the magma that will be moving, rising and sinking depending upon the heat transfer. So in case of this core mantle boundary, here the core mantle boundary is also called as D layer. So this core mantle boundary has the highest temperature range that is recorded in the Earth. So that is about 5,000 degrees Celsius to 6,000 degrees Celsius in case of this D layer or core mantle boundary. Here, all the materials are heated very high, immense amount of heat. So whenever it is got a high heated condition, it will lose its density. So whenever the less denser material along at the core mantle boundary will be tendency to move towards the upper part of the mantle because of the less density. Whenever this less denser materials are migrated due to the density into the upper part of the mantle, it will be gets cooled. Whenever it is cooled, the density will be high. Then that material will be that will sink towards the core mantle boundary or bottom part of the mantle. So this circular movement takes place by the heat transfer because of the density. So the density will be less in case of the high heater area of the mantle, and the density will be high in the case of the less heat area of the mantle. So this circular movement of the mantle material will be continuously moving. So this kind of movement will be takes place about 200 million years for the one complete rotation. Okay, so the mantle is circulating by the convection current. So above the mantle or the asthenosphere, these plates are situating. So because of this cyclic movement of the mantle, so these lithospheric plates are continuously moved above the mantle. So this will cause the movement of the plates or the plate tectonism. So this is a kind of movement of the plates, movement of the what you call the convection currents. This is a core mantle boundary. It will be heated and the magma will be rise into the upper part of the mantle. It will be gets cooled. Whenever it is cooled, the magma will be have got higher density. So this magma, high density magma will be again sink into the core mantle boundary. So this cyclic movement will happen. These plates are moving along the asthenosphere of this mantle. So this is the first our plate movement over time. In case of the 200 million years ago, all the continents are fit together. That is called, the single continent is called Pangea. So this single continent is get diverted or that detached by this movement of the plate movements, plate tectonism. So in case of the Triassic period, it is get distracted. Some divisions are formed. Here you can see here the divisions are formed. Here you can see the African continent and South American continent fit together. So later time in the Cretaceous, they are separated to form. Here you can see the separation is happened. The plate movement takes place where the Atlantic Ocean is formed. So there is no kind of Atlantic Ocean in the this slide. You can see this slide has no kind of any kind of movement of Atlantic Ocean. Here you can see the formation of the Atlantic Ocean. So in the present day, we can see so all the continents are arranged in this specific manner as in case of the present day. So this is the process of plate movement happen throughout the time. So this also happened by the plate tectonism. So it is continuously happening in the Earth's surface. So because of the plate movements, there are different kind of plate boundaries are formed. So we can say that this is divergent plate boundary, convergent plate boundary, and transform plate boundary. Whenever the plates are, primarily the plates are moving diverging. First of all, the plates are moving apart. So the mantle magma will be rise beneath the surface, beneath the crust. So it will be forming as a wedge. When the magma is applying into the wedge, the plates are moving apart. So this kind of movement is called a divergent plate movement. So the most interesting feature that is formed in the every ocean middle part is called mid-Atlantic ridges is formed by this process. And also the number of seafloors are formed by this kind of divergent plate boundary process. So the seafloor spreading is the most important process that is associated with this divergent plate boundary. Here you can see the magma will be rise and the continental part will be fractured. When after the fracture will be diverged, the divergence will be happen continuously. So the fracture will be diverged to form rift valleys. And again, this continuously happens in the rifting. The water or the seawater will be accumulating in the valleys to form seafloors. So extensively these seafloors are continuously spreading. So especially in case of the Atlantic Ocean is also formed by this process. The African continent and South American continent are separated to form 6,000 kilometers of Atlantic Ocean. So this is associated with the divergent plate boundary. And another boundary is called convergent plate boundary. Convergent plate boundary is that two plates are moving towards each other. The convergence happens. One plate will be subducted into the asthenosphere or mantle. So the subducted part is also called Benioff zone or seismic zone because one plate is overriding with another plate to form number of fractures producing in the subducting zone. So these fractures will be produce seismic waves, and this seismic waves will be act as the different earthquakes or focuses as in case of the subduction part. So this subduction part that is associated with the seismic properties are called Benioff zone. So this is associated with the convergent plate boundary. So this convergent plate boundaries are in different types. There are oceanic-oceanic convergence, oceanic-oceanic plate convergence, and oceanic-continental plate convergence, and continental-continental plate convergence. In case of the oceanic-oceanic convergence, whenever one denser plate will be subducted into the mantle, so it will be produce trenches. The most tremendous feature in the Earth's surface is the oceanic trenches, will be formed. As an example, for example, Mariana Trench. And also island arcs are formed. The Hawaiian Islands are formed by this. Because once plate is subducting, it will be reaching in the mantle, it will be reached in the mantle, it will be started to partial melt. It will be started to produce magma by the melting of this plate. Right? This magma will be less denser than that of the mantle. So this magma will be rises into the crustal part or plate part. So it will be formed as the volcanic mountains. So this is the two interesting features that is formed in case of the oceanic convergence is called trench and oceanic trenches and island arcs. And in case of the continental oceanic, one continental plate is subducting, one continental plate is collided with one oceanic plate. So it will be formed as a one trench, oceanic trench will be formed. And by this subduction, here you can see here the partial melting will be happens. This magma will be raised into the continental crustal part. This is called volcanic arcs. So the most important volcanic arc ranges are Andes mountain ranges are formed like this. Okay. And another kind of plate convergence is the continental convergence. Two continental plates will be converged, especially in case of the Indian plate and Eurasian plate. This is the best example for the continental convergence. So these two plates are less denser. The continental plates are less denser than that of the oceanic plates. So these two plates will be collided and overridden with each other. This will not subduct. It will be override each other. So whenever the overriding happens, there is numerous folded mountains are formed. Folded mountain range will be formed in case of the overriding plate. So that is example. The Himalayan mountain range is the best example for this, what you call this kind of continental convergence. So this is a continental plate boundary. And another plate boundary, the transform plate boundary. Whenever the transform plate boundary happens by two plates are slide past each other. The movement is sliding each other, parallel movement. One plate is moving, sliding to another continent, another plate. So this is happens by the, in case of the continental plates. So this is formed the interesting feature, San Andreas Fault in California, that is about 1,200 kilometers throughout the California. So this is another kind of plate boundary, transform plate boundary. So there are three kind of plate boundaries by the plate tectonism. One is the divergent plate boundary. It will be the plates are moving, driving apart. And another kind is the convergent plate boundary. That is the plates are moving towards each other. And another kind of plate movement is the transform plate boundary. That is the plates are moving, sliding past each other. So these are the most important three kind of plate boundaries associated with the plate tectonism. So this is the Earth's most common plate boundary areas. So this part is commonly known as seismic belt of the Earth, because whenever the continents are moving apart or colliding or sliding each other, there will be the process of seismic activity and volcanism. Most of the volcanic activities and seismic stations or earthquake process are associated with these plate boundaries. Here you can see the South American plate and Cocos plate. This is the oceanic plate. Cocos plate is oceanic plate and South American plate is the continental plate. Here is the collision. You can see that here is the collision between Cocos plate and South American plate. Here you can see the boundary has number of seismic stations or seismic activity will be reported in this area, and also volcanic activities are also reported in this area. So this area is called, this dark spots are the volcanic mountain ranges, especially that is Andes mountain ranges, and this red spots are seismic or the earthquake process are reported in this area. Here you can see the Pacific plate directly collided with North American continental plates. So here is the collision of the oceanic and continental plate. Okay, here you can see a line that is running through the, here is the distribution of the earthquake that is running through the Atlantic Ocean. Here is the African continent, here is the South American continent. Here you can see the linear line of distribution of the earthquakes in this is the Atlantic Ocean. Here is the mid-Atlantic ridge. So that mid-Atlantic ridge is formed by the separation of the Africa and South America. So here is a divergent plate boundary. Here also earthquakes are reported, but that is not something what you call not dangerous, because it is in the middle of the sea, middle of the ocean. Okay, so these are the different kind of properties associated with plate tectonics. Thank you.